In this lecture, we're going to look at literals in detail. A literal is a piece of data that doesn't live in a variable in your code. It lives directly in your program executable. So what do we really mean by this? Suppose we have a variable called int var and we have a value inside. This variable is going to be allocated space in the memory of your computer, and that's where we're going to store this value. But if you look at this 55 here, it is a literal. It is a value that is actually going to be burned into your binary code, and it is what we're going to be using to actually initialize this int var variable of ours. Here is a slide that I have stolen from one of the previous lectures where we learned about the C++ program execution model. And we have a few variables inside. We have A, which is going to be an int. We have B, which is going to be an int. And we have a couple of other statements. What I really want to show you here is what happens when this program is loaded in memory. And we have this red section in RAM when the program is loaded in there. You see that these values are in there literally. And that's actually why they are called literals. They don't have to be represented in memory or anything. We have a 10 and it is burnt into the program executable, and that's going to be actually stored in the program area or code section in memory literally. That's what we really mean. So why is this different from regular variables that we have been using all along? If you look at A here, and we have that in our program section, this is actually an instruction to the CPU to create a memory location somewhere. And that's what we're doing here with this yellow thing here, A and B. The CPU is going to allocate memory somewhere, and it is going to copy this value and store that in that memory location. And we will be able to use these names A and B in our program to do things. So there is a very big difference between these two things. The 10 and 5 here we have are literals, but A and B are variables, and we are copying data from these literals and putting that in these variables so that we can use that in our program. For example, here you see we are taking A and adding B, and we are going to store the result in C here. So this is the difference. A literal is stored directly in your program binary code, and a variable isn't. A variable is allocated some space somewhere, and data is copied from literals and stored into memory locations that are assigned variable names. I really hope this makes sense. So in C++, there are a few tricks you need to know to work with literals, and we're going to be learning about them in this lecture. If you look at the example code here, we have a few variables declared, and we have to be very careful in how we initialize this to make it clear to the compiler that the types we are initializing with are what we intend. For example, here we have unsigned car, and we have to make it clear that the value we put in here is unsigned. Otherwise, we may get a compiler error. And we have a suffix for this here. The U thing here means that this is unsigned. If you go down here, you see that we have a few short types, and we have seen this before, but this time we are emphasizing that we are initializing these variables with literals. And you see in the comment here, we say that we have no special literal type for short. And what we mean here is that we don't have a special suffix we can add to this to mean that it is a short. The compiler is going to know this from this modifier that you put here. Here we have a few other variables qualified with the long modifier, and we have a special suffix we can use in our initialization to make it clear that we are putting in a long piece of data. We use the suffix L to do that. This L can be either uppercase or lowercase. It's really not going to make a difference. And if you go down here, you see that we can actually combine long and unsigned, and this is how you do it. You can use UL as a suffix. We also have long, and we can use LL as a suffix to mean that this is a long literal that we are using to initialize our variable. C++ allows us to make our initializers a little bit readable, and you can use this single quote to separate your numbers into groups, and this is going to have different meanings in different languages. But you can use this to make your code much more readable. And you see that we are using U to mean that this is an unsigned literal. And we can print this out if we want. And another thing I should really point out is that if you print this out, these single quotes are taken out because this is really meant for the programmer reading this piece of code. It's not meant for whoever is going to see what you print out. So the programmer is going to look at these single quotes and have an exact meaning of what you mean with this unsigned literal here. And another thing we have seen before is that we have to be very careful about narrowing errors. For example, here we have an unsigned character variable, and this is going to take up 1 byte in memory, and its range is going to be really limited because it can store values between 0 and 255. If you try to put in something bigger than that, you're going to get a compiler error if you have initialized this with curly braces or braced initialization. And if you have used functional or assignment initialization, you're going to get a silent failure, and this is going to be very bad. So be careful about that. Here we have another example. We can make it clear that we are initializing with a hexadecimal number. So we can use the format that we are now familiar with. If we prefix with 0x, we are meaning that this is going to be a hexadecimal number. If you prefix with 0, hex number 2 here is also a hexadecimal number because we are using 0x. And this 0x thing is going to make it clear that this is a hexadecimal literal. Okay, so these suffixes and prefixes are really there to tell us what kind of literal we are initializing our variables with. And down below here, see that we can, for example, initialize colors with these hexadecimal numbers, and this is going to make it very easy to work with colors. For example, we can print this out, and we have seen that we can use manipulators on stdcout to see this in hexadecimal format on the terminal if we really want that. Here we have an example with octals. So we are initializing our variable with octal literals, and you see that we want this to be unsigned. So you can really combine these things. And be very careful with octal literals, because some people may look at this and think that you are initializing this variable with decimal 55. That's not true. This 0 prefix means that this is actually an octal number. And if you transform this to decimal, you're going to get a 45. So be very careful about this. You can also specify binary literals, and you have to prefix them with this 0b thing. And if you want it to be unsigned, you can specify that using our u suffix. And if you print this out, you're going to have this value here printed out, and it's going to be printed out in decimal by default, but you can put manipulators on stdcout to see this in whatever format that you want. We can also have character literals. We can have int literals. Int literals don't have a special suffix. We can have float literals, and we have to be careful and put this f suffix if we want this to be a float. If we don't put this f here, it's going to be interpreted as a double in memory. We can also have string literals, and you initialize this with quotes like this. But we're going to learn about strings in detail a little later in the course. The main message here is that this is a string literal, and we can print it out if we want, and we're going to see it printed out on the console. Okay, so this is really all I have to share about literals. The information can be overwhelming, but the main point is that literals don't have a location in memory. They are burnt into the binary of your code. And you have to use special prefixes or suffixes to specify what kind of literal you are initializing your variable with. And we have seen a lot of examples about this. Now we're going to jump into Visual Studio Code and actually see how you can use this in real code. Here we are in our working directory. The chapter is literals and constants, and we are learning about literals. we are going to do the usual and copy our template files, and we're going to be pasting this in our current lecture. We are going to open this up in Visual Studio Code, and we are going to open up our main CPP file here. Let's take out things we don't need. We are going to put in our starter code so that we can play with this. And this is nothing really special. It is everything we have talked about in the slides. You can use special suffixes to give meaning to your literals that you are using to initialize variables. For example, this is going to mean that this is an unsigned literal, and anybody using your code will see this immediately, and the compiler is going to understand this. We don't have special suffixes for short, so we will have to initialize them like this. But if a short is also unsigned, we can make this clear. And another thing we have seen is that we can either use lowercase or uppercase. This is not going to make a difference, and you can use whatever you want. If we go down, we really have nothing special here. For long, we have the L suffix. We can use that. And for long, we can use LL to mean that this is a long literal. Another thing that can be really useful is that you can use this single quotes to really divide up your number. If you hover over it, you're going to see that in memory, these quotes don't really mean anything. They are meant to make it easier for the programmer to have a direct meaning of what this number is. And if you print this out, you're not going to see these quotes. So let's try and print out some of these things. So for example, if we print the long here, so let's grab the name, and we're going to go down and say stdc out, and we're going to show this and put this on the terminal like this. And if we open our terminal and build this with GCC as we usually do, the build is going to go through, and if we run this, we should see two messages. The price is this value here, and you see that we don't have the quotes. Okay, so these are just a few examples to show you how you can use literals in your code. We have really done all this before, but right now we are emphasizing on the fact that these are literals, and these numbers here don't get stored in any variable. They are burnt into the binary of your program. Let's look at another example and show you a few narrowing errors you can run into. Here we have a car variable, and it can really store values between 0 and 255. But you see that we are putting in 555. So this is not going to fit into memory, and we are going to get a compiler error if we are lucky. Or if you are using a less safe form of initialization, like functional initialization or assignment initialization, this is going to fail silently, and you're going to have a junk piece of data in this variable here. So be careful about that. Let's try to build and see what we get. And you see that we actually get a compiler error. The compiler is going to stop us from making this mistake here. Okay, so this is also unsigned, and we are putting in a negative number. So this doesn't make sense. The compiler is going to stop us. But if we were using functional initialization, let's change this up a little bit, and we tried to compile the program. Let's do this with GCC. We're not going to get a compiler error, we're going to get a warning. And this may be really bad, but this compiler is actually good because it's letting us know about this problem. Some compilers are going to silently store in a bad value, and you're not going to even notice that. I think we don't have a warning on this game score thing here. So let's comment this out and try to build again with GCC. And you're going to see that this is going to go through. But we have said that game score here can't store a negative number because it is unsigned. And if we try to print this out, we're going to get some really bad number. So let's try and print this out so that you can see this. And we're going to say game score, stdendl. Let's build and see what this actually is. It is a good learning experience. If we run this, you're going to see that game score is this big number. So what is happening here? The compiler is trying to put in -20, but this value is going to have a completely different interpretation because unsigned int can store negative numbers. And we're going to learn about what is actually happening here in the next chapter. But for now, know that sometimes this is going to fail silently, and you're going to work with this really huge value thinking that you have a minus 20 in there. So be very careful with your initialization here. Let's turn this back to braced initialization because that's actually much safer. And we should be good now. If we try to build, we're going to get proper compiler errors if we make mistakes like this. And this is a good thing. Let's comment this out because we still have a few examples we want to do. There is also a special syntax you can use to mean that your literal is a hexadecimal number. You can prefix that with 0x, and we have a few examples here. We can print this out to see what it looks like on the terminal. We're going to build with GCC, and we can run our program. And the hex number is 555. It is 1024. It is this value here. So we are initializing these things with hexadecimal numbers, but what we print is in decimal by default. And again, if you want to see this printed out in hexadecimal format, we have seen a few things we can use. For example, we can use a manipulator to make this work. For example, we can use std hex as we have seen in the chapter on manipulators. Let's try and build this and see if it goes through. If it doesn't go through, we're going to fix this. Okay, the build is good. Now if we run our Rooster program, we're going to see our values printed in hex. And this is a sticking setting in that if you set it up, all the integers you're going to print are going to be printed in hexadecimal. So if you want to disable this, you have to explicitly set the others to use decimal. And we can do that, no problem. So we're going to say stddec to mean that we want this to be in decimal. And we want the color to also be in decimal. So we can say that. Let's say std decimal. And if we build, we're going to come to terminal, run the task to build with GCC. The build is going to go through. And if we run our program, we're going to see it in the format that we want. The first one is in hex, but the following ones are in decimal because that's what we explicitly said here and here. We can also use octal and binary literals. Octal is going to be meant by the prefix you have here in front. So don't think that this is a decimal number, 777. It is going to be an octal number. And it is going to be transformed to decimal 511. Here we have another example. We put in octal 055, which is going to be 45 in decimal. And if we print this out, it's going to come in whatever number system we have specified in our stdcout statement, or it's going to be decimal by default. We can build this and see what it looks like on the terminal. The build is going to go through. If we run, we're going to see our numbers. So octal number is 511, what we expect here. And we're going to see that our 55 is going to be transformed to a decimal 45. And our color is also going to be printed, which is going to be 255. And that's what we're going to get here. But we have initialized this in binary format. And this may come in handy in some applications. Okay, we're going to do the last example. We have seen that we can also use other literals. For example, a character literal is going to look like this. This is going to be a regular int. We're going to put in a 15. This is decimal. And if we print this out, that's what we're going to get. Here we have a float. And we have a special suffix to mean that it is a float literal. And if we hover over this, we're going to see that it is a float. But if we forget this f, and hover over it, you're going to see that it is going to become a double. So we're going to be initializing our float variable with a double number. And there is potential for losing data because doubles are bigger than floats in memory. And we have seen this before. To really play it safe, you have to be very explicit and mean that this is a float. And you can do that by putting in this f suffix. And if we hover over this again, you're going to see that this is a float. Visual Studio Code can even understand this. We can also have string literals, and this is how you work with them. If we build this with GCC, the build is going to go through. And if we run, we're going to get our literals printed out. The character is going to be C. The number literal is 15. The The fractional number is 1.5 and the string literal is hit the road. This is really all we set out to do in this lecture. I hope you have a better idea of what a literal is, and you know a few suffixes and prefixes you can use to be very explicit about what you are using to initialize your variables. We are going to stop here in this lecture. In the next one, we're going to learn about constants. Go ahead and finish up here and meet me there.